In this example, we are going to test on a small data set with a moderate slope and variance to generate a typical p-value and confidence level. This high p-value suggests weak evidence against the null hypothesis, indicating that the observed slope and intercept could reasonably be expected if the true slope were 1.5. We'll look at the slope with 99% confidence level, and it indicates that the mean estimate of the true slope is 1.59. So we'll run the simulation again on the adjusted slope and see the results. Now we will make the slope 1.6, and we can see that the p-value for the slope is now 0.1, which indicates that the null hypothesis is unlikely, but it is not low enough where there is statistical significance. Since the confidence interval includes the hypothesized slope of 1.5, it further suggests that there is no significant evidence to conclude that the slope is different from this value. Now we will look at an input with a high slope and low variance, which will lead to a very predictable relationship. You can see that there is a low p-value for the slope. The distribution in the histogram indicates that the slope does not strongly deviate from the observed slope, indicating a fair amount of alignment with the hypothesized model. The confidence interval is pretty narrow and is set to 99%, indicating that the true slope is within this range and the mean estimate is close to the true slope. The p-value and confidence interval show that there is strong evidence for the slope having significant effect on the hypothesized model. When we run hypothesis testing on the intercept, the observed value is somewhat lower than the hypothesized intercept value. While a p-value of 0.06 does not mean statistical significance, it is close enough to suggest a potential deviation from the hypothesized intercept of 0.5 and proximity to the intercept where the regression line crosses the y-axis.